September 2018 with me Nur Naziha from Kolej Matrikulasi Selangor. Serve you the updates new nowadays for 10 minutes. Your news is our business. Recombinant DNA is a series of procedures that are used to join together DNA segment. A recombinant DNA molecule is constructed from segments of two or more different DNA molecules. Under certain conditions, a recombinant DNA molecule can enter a cell and replicate there either on its own or after it has integrated into a chromosome. So now our Malaysian scientists has found a solution in form of an antivirus to cure cancer. From this we can help to save a lot of lives as the cancer is the second highest number of cause of death in Malaysia. So here we have Professor M and Professor R. They will explain about tools used in recombinant DNA technology.
So now I will show you the tools of DNA technology. First is target DNA, which is a sequence of DNA containing gene of interest. Next is restriction enzyme, which cuts the DNA molecule at a restriction site and produce short restriction fragment. EcoR1, which produced by E. Kolej. It will cut the bacterial cell into staggered cut. Next is small one. It is produced by Serratia marcescens. We will cut the bacterial cell into blunt cut. Next is DNA ligase. It will after the bacterial cell is being cut, it will bind them into a recombinant DNA.
Vector is a DNA molecule which can carry foreign DNA fragment into a host cell and replicate in that cell. So in this experiment, we choose plasmid as our vector. Why? Because plasmid has lots of characteristics that suits this experiment. First, plasmid is able to accept foreign DNA in multiple cloning sites. Second, plasmid is able to replicate freely in the host cell. And last but not least, plasmid is able to possess selectable genetic marker. Next, host cell is a cell which receives a recombinant DNA and allows the replicate of recombinant DNA. The characteristic first of all, host cell we use is E. Kolej, or known as Escherichia coli. E. Kolej is special because it is able to receive recombinant DNA through transformation process. Secondly, E. Kolej is able to maintain the structure of recombinant DNA from one generation to another. Last but not least is E. Kolej is able to amplify the gene product from the recombinant DNA. And that's all for the tools of recombinant DNA technology. Thank you.
So now we have Professor Yu and Professor N. They will explain about steps in gene cloning. So first step is isolation of gene. First we take the bacteria plasmid from bacteria cell, which from this example we use an E. Kolej. And the gene of interest for target DNA. So the next step is called cleave and cut. So gene of interest from our target DNA and also the plasmid, bacteria plasmid for our bacteria cell is cut using a compatible restriction enzyme. So in this type, since we're using an E. Kolej, we are using EcoR1 as our restriction enzyme. So we are going to cut our gene of interest using a sticky end. Step is insertion. So from the
our gene of interest has been cut using a trigger and is inserted into our bacterial plasmid using a DNA ligase. So we stick using a DNA ligase to combine the cell.
Next step is transformation and amplification. The recombinant DNA then inserted into the bacteria or host cell through transformation process. As the bacteria reproduce, the recombinant DNA is also replicated. The screening process. To identify bacteria clone containing recombinant DNA, blue-white screening is done. Plate the bacteria on agar containing antibiotic, ampicillin, and sugar, agar. Incubate until colonies grow. There are two colonies grow, which is white colonies, the recombinant plasmid that cannot hydrolyze, and blue colonies, the non-recombinant plasmid that can hydrolyze. So now let's re-enter the lab and we can see our scientists are busy prepare their stuff.
This is a Chucky Beat production.